The differential operators in rectangular coordinate system is quite easy, but in different coordinates it is difficult to present and memorize. So let us generalize these concepts for all type of coordinate system so that it becomes easy to understand and write for all type of coordinate system. So let us start from gradient. That is, gradient of V can be written as, in generalized form, 1 by h1 dv over du in the direction of AU. It will give a vector quantity 1 by h2 dv over d small v in the direction of AV cap plus 1 by h3 dv over w in the direction of AW, where u, v and w can be, and w, it can be a rectangular coordinate xyz respectively, and rho phi z in cylindrical coordinate, or theta phi in spherical coordinate. So this is generalized term for gradient of V in any coordinate system. Now let us talk about cylindrical. We will talk about H1, H2, H3 after some time. Now after gradient, we will talk about divergence. And we know divergence can be written as del dot any vector. Okay. In generalized form, it can be written as h1, h2, h3 in bracket du d. This is first, so it will be h2 multiplied with 3 and AU component of vector A, plus it will give you a scalar quantity, so there is no unit vector, d over d v, this is second, so h3 and h1 multiplied with a component in the direction of v, and further d over dw, h1 h2 aw. Hope it is okay. So this is generalized form either in rectangular coordinate system, if you will put x as u, u as x, v as y, w as z, then it will be rectangular coordinate. In spherical, u will be r, v will be theta, and w will be phi. Now gradient, divergence. After that, let us talk about curl, and curl can be written as this, and it can be generalized as h1, h2, h3 as it is here, and this will be vector quantity. So it will give you h1 in the unit direction AU cap, H2 AV cap, and H3 AW cap. The first row will occupy these elements, and here D over DU, D over DV, D over DW. Here it will be H1 times the component of A in the direction of AU. Here H2 times the component of A in the direction of V and A in the direction of W. Leave the Laplacian. You can write, but leave it. So because I have seen the gate paper, it is never asked in the exams. So leave it. Either, okay, write it here. You can write Laplacian of field. You can say D dot D del dot del V. This is gradient divergence of gradient of V. It can be written like that. So in generalized form it can be written as similarly 1 by H1 H2 H3 and in bracket D over D U. First term is there, so H2, H3 and H1 will be here with multiplication of this in the direction of AU plus V, this is second, so H1 H3 divided by H2 AV plus H2 H1 divided by H3 AW. This is Laplacian. Now let us see what is H1, H2 and H3. This is generalized form. So in different coordinate system we will see what is H1, H2 and H3. So let us start from rectangular coordinate. In rectangular coordinate, right, first one is U, second is V, third is W, H1, H2 and H3. So in rectangular coordinate, U will be X, V will be Y and W will be Z. And this is simple, H1, H2, H3 will be 1. But in cylindrical coordinate, what will be X? I think we have discussed it very well. That is rho. Phi, Z will remain Z. What's about H1, H2, H3? If we relate from previous study, then we find 1, rho and 1. What's about spherical case? U will be radius of the sphere, V will be theta and W will be phi. in the xy plane the angle made by the position from x-axis. And h1, h2, h3 will be 1 relate from the previous study r sine theta. So this is the generalized equation. Now on the basis of these explanation, let us try to write gradient of v in different coordinate system. So let us write gradient in different coordinate system. So for that purpose, gradient of v was written as here. So in rectangular coordinate, it will be 1 by h1 is 1 del v over del what is u x plus 1 by in the direction of a u will be x plus 1 by 1 because h2 is also 1 del v over del small v will be y in the direction of ay plus del v over del z as w is z in the direction of a w is z, so in the direction of z. So divergence can be written in for rectangular coordinate system like this. Now in cylindrical coordinate system, it can be 1 by h1 is 1 del v over del rho, because in cylindrical u will be rho, v will be phi and w will be z. So del v over del rho in the direction of a rho plus h2 will be, h2 is rho, so it will be 1 by rho del v over del v is phi in the direction of a phi plus 1 by h3 is 1 del v over del z in the direction of az. In a spherical coordinate, gradient of v can be written as, on the basis of this formula, 1 by h1 del v over del r as u is r in the case of spherical coordinate system, ar plus 1 by h2 is rho, sorry, h2 is r del v over del small v will be theta in the direction of a theta plus h3 is r sine theta del over del w is phi in the direction of a phi. So gradient in different coordinate system on the basis of this generalized form can be written like this. Now let us try to find the divergence from this generalized form for rectangular, cylindrical and spherical coordinate system. So divergence that can be written as divergence of vector field V, or you can say, if here written A, then write A for simplicity, is equal to, as it is written 1 by h1, h2 and h3, and in rectangular coordinate system it will be h1, h2 and h3. So 1 by 1 multiplied 1, it will be 1 by 1, in bracket 1 del over del u will be x, ax plus del y, ay plus z, az. So that is the simplest one. Need not to worry about this. But in case of cylinder and spherical, it will be quite different. So cylindrical case, write down the divergence of A like this. 1 by h1, h2, h3 in case of cylindrical case will be 1 multiplied rho. It will give you 1 by rho. Okay. Now partial derivative of H2H3 rho A rho divided by del rho, because the u is rho in the case of cylindrical coordinate system, plus phi, and the multiplication will be H3 and H1, A phi. H1 and H3 will be 1, that's why I have not written anything here. As W changes to phi, W changes to Z in case of cylindrical. So AZ. Hopefully there is no problem. In case of spherical, divergence can be written as 1 by h1, h2, h3, 1 by h1, h2, h3, 1 by r square sine theta for all. Now inside it will be del over del r h2 h3, that will be r square sine theta multiplied with au. U is rho, a rho, plus second is theta, del over del theta, H3 and H1, r sine theta, a theta, plus del over del phi, H1 H2 r a phi. So now let us solve some numericals based on the differential operators in different coordinate systems. So let us start from the first problem, that is, if a scalar field is given as rho square z cos 2 phi, find the gradient of the field at the point 1, 45 degree and 2. So this is the point. So after seeing the problem, the first thing that we should write is the finding the gradient, that is gradient of any field A is written like that. Okay. The second point that can be from the coordinates of the point, we can judge in which coordinate the problem is talking about. So from the coordinate present here, rho, phi, z, we can say it is in rectangular coordinate system, and the gradient in rectangular coordinate system we know properly 1 by h1, that is 1, del A over del rho plus 1 by h2. h2 is rho in that case. Just before few minutes we have discussed this, and that can be written as del A over del phi plus 1 by h3, that is 1, del A over del z. So this is the gradient of A in rectangular coordinate system. That is simple now. Just simple mathematics is left. Try to solve it. Put the value of A, del over del rho, rho square z cos 2 phi plus 1 by rho, rho square z cos 2 phi del phi, rho square z cos 2 phi del z. Now the only mathematics is left, nothing else. Differentiate it with respect to rho, considering remaining as a constant. So that will be outside differentiation of this. So 2 rho z cos 2 phi plus differentiation of this, remaining will be constant. 1 rho from here, 1 rho from here will be cancelled out. So rho z will be out from here. Differentiation of this will give you minus sine 2 phi multiplied with 2. So it will be minus 2 sine 2 phi. And multiplication of plus and minus will give you minus. Here there is z, so it will give you rho square cos 2 phi. Hope it is fine. Now put the value at which we want to find the gradient. The point is this. So we have to place the value of rho as 1, phi is 45, z is 2. Put it here. 2, 1, 2, cos 2 phi is cos 2, 45, 90, that will be 0. Minus 2, rho is 1, z is 2, sine 2 phi will give you sine 90, that is 1, plus cos 2, 0. I forget one thing throughout the explanation, that was the direction of, because it is vector quantity, the gradient of any scalar field is a vector quantity. So it will be in the direction of rho, it will be in the direction of phi, it will be in the direction of z. A rho, a phi, a z, a rho, a phi, a z, a rho and a phi. So the final answer will be minus 4 a phi.